Hi, nice to meet all of you. It's a pleasure to be here. You know, this is an industry that is brimming with an overabundance of frameworks and roadmaps and commitments to decarbonize. We have been doing this work with a good heart for really more than 10 years, probably even approaching 2 decades. The pinnacle of that commitment is our science-based target commitments to reduce our carbon by 45% by 2030. But as this graph shows, we are not on track to achieve that commitment. In fact, quite to the contrary, we are off track and our emissions continue to go up rather than down to achieve that mission. So, in a nutshell, what has gotten us this far is not going to get us where we need to be. And what I want to do in this talk today is to give some specifics to reorient our work so that we can achieve better results and more success in our decarbonization mission. And the first thing that I'd like to say is that it does require, or I am at least suggesting, strongly suggesting, that we have a mental shift in mindset so that we're thinking about being on a mission instead of being on a journey. Because there are good things about being on a journey, but there's a lot of enjoyment on the way there. And what I would say is a mission to achieve the reduction of 45% by 2030 requires that change in mindset. But more important than a change of mindset, I really want to talk about two tools or two methods of approach that I think will help us to reduce our emissions and come closer to achieving our goals. And the first is for us to much more carefully and quantitatively follow the tons. So would everyone please take out their calculators? Oh. Okay, actually, you don't have to have calculators here today. I'm going to do the math for you. But when you get back to your offices, I hope that this talk will inspire you to pull out your calculators and you can start following your own tons. And the principle behind the talk of what I'll be talking about for the rest of the talk is to focus our efforts where it matters the most, not where it is easiest to start. Okay, and so I'm going to talk about sort of three areas of that focus: where best to start, what reduction opportunities are best when we get to those locations, and then how to best reduce our energy use and emissions that way. This might sound grim, but I'm a toxicologist by training. I could be talking about chemicals that kill you. So we're doing something that's a little lighter touch than that. That's another specialty. Okay, so where to start? Well, most people in the audience are probably familiar with this particular type of pie chart, which shows that the first important focus is in the supply chain in our scope 3, as it is called, and not in our offices or in our retail stores, which, by the way, is the easiest place to start and is where a number of companies spent an inordinate number of years reducing their scope 1 and scope 2 emissions. Once we are in the supply chain, you've also heard today, and it's true, that the vast majority of our emissions are in wet processing and dyeing and finishing, and so that's the juicy areas to start. So both of these things are probably familiar to most people in the room. It's just a review. We're all suckers for hearing what we already know, right? But there's a further concentration of opportunity that may come as more news for you guys, and again, as hopefully a suggested helpful method and approach change, which is that we have an enormous concentration of opportunity for where to find our tons. If you look at the Higg index, the database has 10,000 facilities in that database. And if you look at the 10,000 facilities and you take out your calculator and add it up, you will find that only 1,500 out of 10,000 facilities are responsible for 80% of our carbon emissions in this industry. Okay, so think about that for a second. That's a large number of facilities that contract down to only 1,500 that are giving us 80%. And better yet, when you look at the 1,500, 80% of those emissions come from the top about 300 factories around the world. So what I have just told you is that less than 3% of the facilities that we have in our Higg database contribute nearly 2/3 of the carbon emissions of our industry. All right, this is where we go shopping for our carbon. not in the other places that don't matter as much. And I have something else to suggest for our targeting, because it's not only the biggest emitters. What we really want is the ones that have the biggest potential for reduction, right? That's where we really can find our juiciest opportunities. And those are the least efficient factories that are using the most highly polluting fuels, okay? So it's not just the biggest, but also the least efficient. Now, the problem we've had until now has been that it has been very difficult for us to identify which are the least or most efficient factories. And that is because all the different types of production that we do have all different kinds of efficiencies of energy requirements. If you are manufacturing, for example, mercerized woven cotton, I am here to tell you that is much more energy inefficient, so to speak, or energy intensive than if you're doing some other types of manufacturing. And so what we really needed, it was impossible to go factory to compare, because we were comparing apples to oranges every time. And until just really very recently, it was actually impossible to easily know how efficient a factory was without doing a lot of hands-on work. But I am happy to tell you that there has been just recently released new performance benchmarks available for the industry that basically provide typical, not best case, typical energy use and emission figures for every type of production that we have in the industry. It's an enormous Excel spreadsheet, basically, and easily allows us to appraise individual facility performance against these benchmarks. And although I don't have time to go into this, this is a tool that the Apparel Impact Institute has put out. They are doing a test with 100 factories and then are prepared to roll it out to more. Basically, there are key figures for typical performance in this large database. You enter your type of facility, type of production, your volume of production, and information about the fuels that you use, and it will automatically calculate for you your efficiency, and then you can compare against the benchmark and see where you fall. So, where to start, okay? In a nutshell, we want to prioritize our biggest emitters with below average efficiency compared to their benchmark. Got it? Okay, next. What reduction opportunities should we be looking for now that we are in the right places? For this, we again need to focus where it matters the most. And this is information that I think is somewhat known already to suppliers and somewhat known or should be known to innovators who are looking for where to make their biggest impact. But what we see when we look at processes is that different processes have different hotspots for where their energy is used. So, for example, if you're looking at polyester, the drying and finishing of polyester is where most of the energy is used. Whereas if we're looking at a cotton batch process, what we see is it's sort of more evenly divided between the prep, the wash-off of dyes, and the drying and finishing. So again, there is a handy, relatively new tool available for us called the Ready Reckoner. I just love how British that term is as an American. We never say reckoners. That provides the energy use for sub-processes for each type of process, and then that in fact is the information that has been rolled up for the performance benchmark standards, so that that's how they got to those total numbers. So again, focusing where it matters the most, we're talking about those facilities that were the hotspots we talked about at the beginning, and then the processes and sub-processes, using either the Ready Reckoner or using typical expert assessments who come in and tell you where your energy efficiency opportunities lie. Okay, last but not least, how to reduce these emissions once we are finally within the hotspots, within the right facilities. And for here, we need to talk about what are we really looking for in our solutions. And there are 3 criteria to look for in the solutions to maximize our results on our mission to achieve our reductions. The effectiveness of the solution, the reach of the solution, which I will define for you in a minute, and the ability of that solution to come to scale. So effectiveness is what it sounds like. It's what % reduction does the solution offer compared to the conventional way of doing business, okay? So reduce by 50% the energy used in drying polyester. You're already interested in that one, right? That's the effectiveness, is the 50%. Reach is also very easy to understand, maybe sometimes more overlooked, which is the breadth of the solution. How much of the industry would that solution really be able to incorporate for the reduction, and which processes and sub-processes would it be able to impact? So, for example, not to go on and on about drying, which I'm sure you're already sick of hearing about, but if a dryer was similar across all different types of fabric production, and there was a solution with 50% effectiveness for all drying, such as, for example, perhaps making sure that fabric is not being over-dried, then that would be a solution with wider reach. And the last one, last but certainly not least, is the ability of a solution to come to scale. Because we have some solutions that are fabulous, but they might have a natural limitation to how big they can get, for example, because the raw materials that they need are just not very plentiful. And so that's a solution that will have a natural constraint to its ability to scale, as opposed to other solutions that nothing much is stopping them except for, the market need for it and the finances, which is way big enough. And so for that third one then, what we are really looking for is to prioritize solutions that have maximum effectiveness, maximum reach, and maximum ability to scale. I'm just about to wrap up, but I too want to talk about electrification, which I was interested to see was also a key point of interest for a couple of the other speakers that came before me. Because as someone mentioned, quite a bit, I have 60%, you heard earlier, 80% of the energy that we use in the industry in wet processing is thermal energy, that is steam. And we make that steam mostly by boiling water with fossil fuel heat, most often coal. And electrification, what that offers is the ability to make heat without burning those fossil fuels. And the two prime examples of electrification are industrial heat pumps and electric boilers. So what I'm here to frame out for you is that the reach of this solution is massively interesting to me. I gave it an A++ for reach, because theoretically anyway, it could cover all of that thermal electricity. Or fine, in fact good, do what you can for efficiency to reduce it because the price of electricity is high. And then with the residual need for electricity, solve those problems with industrial heat pumps or with electric boilers. So, reach grade, really good. But what I want to focus on for a second is the effectiveness grade, because effectiveness, it depends. What it depends upon is clean electricity. Okay, that's the key to the kingdom on this one. Because if you're generating electricity with coal, you're merely taking the emissions that would have come from the industrial boiler and putting them at the power plant, and you really haven't done any good for planet Earth with that kind of thing. So then we start looking at things like a cleaner grid and renewables, on-site and off-site, et cetera, to make sure that the electricity that we're using is actually clean electricity. And luckily, experts are already sort of benchmarking how clean does the electricity need to be, how clean does the grid need to be in order to kind of come out ahead and be in for the win, so to speak, with electrification. And steam heat pumps actually require less clean electricity for various reasons than the electric boilers. And that level of cleanliness of the grid is easier to find around the world, whereas for the moment, electric boilers require cleaner electricity than we tend to have anywhere except in Europe and some places in the United States. So I think I'm wrapping up. How are we going to achieve our mission to reduce by 45%? In terms of where to start, we have the tools in hand. We want to be prioritizing our biggest emitters who are below average efficiency compared to their benchmarks. In terms of what reduction opportunities we want to focus on first that matter the most, we also have those tools in hand to help us focus on the hot spots in production using tools like the Ready Reckoner or expert assessment. And then I have to say, in terms of the solutions, I think we're in progress because I would say that we are still working to bring the very most effective solutions with the widest reach to scale. But luckily, we have a deep dive just on this topic this afternoon, and the 45 of you who have signed up will hear from a colleague organization of mine, Fashion for Good, that are doing fabulous work on bringing solutions to scale, as well as some of the work that's going on in the Apparel Impact Institute. And we'll have, I hope, a very rich discussion there with some brainstorming of how to help to better bring these very promising solutions to scale. Thanks very much.